Hello guys, welcome to my YouTube channel Scholar Tech Studio. In this video we are going to find the force acting on a spring damper system in static equilibrium condition if the mass of the body is 187.224 kilogram and the spring constant is 5 Newton per millimeter and the damper coefficient is 0.05 Newton second per millimeter. We are going to solve this problem in MSC Adams View. So we will open the Adams View. So we will open the Adams View from here. Double click on it. Okay. So the first step is we have to create a new model. So we will select the new model. And here we can specify the name like spring damper system, or you can give any specific name. Here we have to specify the direction of the gravity, that is by default in -y direction, and here we have to specify the units that are millimeter, kilogram, Newton second and degree, and here we can specify the directory where we want to save this model. Okay, you can specify this according to your requirement and then said okay. Now we are in Adams View interface. The first step is we have to create a rigid body. So we will go to this part, and from here we can select this one. Okay, and then we can place at the origin of this one. Okay, so here you can see that this is the body is created, and from here we can see that like the body is created. Okay, so now we want to move this like working grid at the center of this one. Okay, why I'm doing this I will tell you later. So for this we will go to the setting, and then we will go to working grid, and here is set the location. So we will select pick, and we will select the center of this point. Okay, now we can see that our grid is moved to at the center point of this one, and from here we can specify this view. And the next point is we have to specify the weight of this body. For that we will go to bodies. From here we can also rename this as our mass body, or you can give any specific name. Okay, and now we will right click on it and then go to modify, and here we will select user input, and here we will specify the mass that is equal to 187.224 and then set okay. So we have defined its mass. Okay, the next step is we have to create a now we need to select a reference point. We will select XY plane, and then we will reference point put it here, and we want the distance from here to here is 4 millimeter. So this is our marker 2. We will do to right click on it, then go to modify, and it's already at 400 millimeter, and we can see it's exactly at the aligned with this point. Okay, so the next step is we need to create a spring damper system from here to here. So for that we will go to force, and under the force we will select a spring. Okay, and we will specify the parameters. This is the K and this is the C. Okay, so we know that K is equal to 5 and C is equal to 0.05. This is the spring coefficient and this is the damping coefficient. Okay, and now we need to specify the location. First we will select this point, and then we will select this point. So the spring has created. Okay, but we also need to create a constant, like this block just only move in Y direction. It's not allowed to move in X direction or Z direction. So for that we have to create a linear joint at the center of this body. Okay, so for that we will go to contact, you can create this contact before assigning this spring damper system. So we'll select this one. First we'll select the ground body, and then we will select the mass. Okay, mass body, and then we will specify the center of mass body, and then we have to specify the location. You can see this arrow is upward direction, and said okay. We have to verify. See, it's created in vertical direction. It's okay. And from here we can set its orientation. Okay, so after that we will go to the simulation, and under the simulation we can find this interactive simulation. Just click on it. Okay, and here we will select the find static equilibrium, and here you can see the operation is complete, and we can zoom out this one. See, okay, zoom in and zoom out. So this is the static equilibrium condition. Okay, so after that we will go to setting, and here we can see that the force graphics, and here we will select the display numerical value and then set okay. So here we can see that the value of the force in equilibrium condition is 1836 Newton. So here is the analytical solution. If the mass is this, then we will multiply mass with the gravitational acceleration. It's equal to 1836.09 Newton, and we have created our results computed with the help of Adams View. It's almost similar. I hope you like my video. Please subscribe my YouTube channel and press the bell icon so that you can get my upcoming video.